Hello all, welcome to my channel. I'm back with another video on the series that we are doing where we explore the certain options of a data platform or a data solution that we are trying to build. So in this video, we will see a few of the key value stores that are at our disposal. So that can we can use to create solutions where we need a key value store. So before we start, just a quick definition for the key value stores are. So what does a key value store mean is a key value stores are a type of NoSQL databases that stores data as simple key and value pairs, where a unique key act as an identifier to retrieve its associated value. So we will have a key which identifies the row or the data that we want to get, and the value will be its uh, whatever that we want to retrieve for a particular key. And this model lacks a fixed schema, so there is no fixed schema in sense of the value part. We just have a definition that we will have a key, which and then we will get a response for that key, and that key can have a value can have a varied schema. It can be fixed schema as well, but it generally is not a fixed schema. So that makes it suitable for applications which require rapid data access through simple get and put or delete operations. And so these key value stores are suitable for caching, storing user sessions, configuring data, configuration data, or real-time metrics, because the way they provide the results is that if we know what we are looking for and if we know the right key, we will be able to get the response of that key in a very quick time. So this is what a key value store is. In this video, we will discuss Redis, Cassandra, DynamoDB, etcd, Zookeeper, Foundation DB, Scylla, Ignite. So these are different key value stores that we have as an option available to us if we are trying to build a solution which needs those things. So let's get started. To start with, the most common key value store that is available in the market is Redis. And another advantage of using or the reason why Redis is so popular is because it is in memory. So the data resides in memory, and so it to write and to read the data from Redis is very fast, and hence it is heavily used in caching systems, because we can just say that okay, we want to store a key, so we provide the key name and the data type of that particular key value, and then the value itself, and that way we can, for example, if something needs to be quickly looked up, we can just plug in Redis in front of the DB so that the caches are updated in the real time. So it is very fast, it is in memory and has a performance which gives us responses even in sometimes in nanosecond and even in millisecond range. So this is very the writes are very fast, reads are very fast, and can handle millions of operations per second. And this is heavily used as well. This is a well battle tested production ready solution which is there for any key value pairs that we have, requirements that we have. The one single drawback of that is that it is single threaded system, which means that it can only process one command at a time, and this can limit the performance and scalability of Redis in applications that require high concurrency and parallelism. So this is good for small scale, small scale in the sense it is good for systems where we don't have that many concurrent access that happening to the same set of records. But if it is for different records, if we are making calls, we will be fine. So this is one very commonly used key value store. Then we have Dynamo. So this is, although I try to keep things which are open source, but I'm discussing DynamoDB in this case because it is very much used, widely available on cloud platforms like AWS. It's only available in AWS, but it is very much used in uh, and it is very common as well to leverage Amazon DynamoDB as a NoSQL key value pair database, which is there. Hence this DynamoDB is also being discussed. Why use DynamoDB? It is totally managed as a service. It is very scalable. It can scale. I mean, it follows the infinite scale kind of solution. So it can keep on. We can keep on adding more and more capacity, and it will handle that. It is single digit millisecond response times, slower than Redis, but yes, it is still. And we can also have DAX, which is the DynamoDB accelerator, which can provide even microsecond responses for cast read heavy workloads that we have. It is highly durable because we have multiple ability zones in which the data gets replicated to, and it is flexible because it can be, it means it is very flexible for us to make the system go from one design to another design in a quicker way. Turnaround time is very fast for this. There are certain drawbacks, like because this is not designed for like a database, so there is no querying capability much. We have to always rely on get and put. And pricing structure is something which is complex in a sense like it is built for indexing, multi-region setup as well. And so it can get expensive as well. Joins is not supported, which is another thing. Vendor lock-in is there because it is only available in AWS. Throughput constraints, we must provide read and write capacity beforehand. So we'll have to just do an estimation of what will be our peak capacity, and based on that, we have to give certain numbers. And if we choose on-demand capacity planning, it will be very costly. And the design of dynamic prioritizes availability and partition tolerance. So it will, so some cases it will lose some consistency. It is eventually consistent system. So that is something which we have to keep in mind working with DynamoDB. Let's look at another key value store, which is available for us to use is etcd. And etcd is a very strongly consistent distributed key value store. That provides a reliable way for us to store data that needs to be accessed by a distributed system. It is the backbone of actually Kubernetes control plane itself. Kubernetes control plane stores all the configuration in etcd database. There are other engines, there are other products which are built which uses etcd as the configuration store. Like for example, we can use if we have any log source system like Parsable or any other systems, big databases which needs platforms which provide configuration support in their platform. They do leverage etcd at a large scale because this is fully replicated, it is highly available, and it is production tested, battle tested. Like it can process or thousands of writes per second, and we can support reads as well very at a faster rate. And it is consistent because it uses raft algorithm to make the leader election and everything. So this is very heavily used, and it is battle tested. So if we have requirement to use a distributed key value store, etcd can be a right choice. It is used in Kubernetes, CoreDNS, Rook, M3. So all these places it's available. Our drawback is that with more nodes, writes to etcd data becomes slower, and the reason for that is the disk fragmentation, and which is mentioned next. That we have seen, like if you manage more than 7,000 or 8,000 nodes in Kubernetes cluster, that time you will notice there's kind of defragmentation issues that comes, and also the maximum size of the data limit that is there is of 8 GB, which is something we have to take care. So etcd is something which we can look, and it's very good solution when it comes to using key value stores. Another solution to that is Apache Zookeeper. This is being used in many of the projects which are there are out there in the market. Like it is used by Ambari. It was used by Cloudera. I'm not sure currently it is used by or not. It is used by Flink. It is used by Kafka. Now Kafka doesn't use it because they have moved to Kraft. So yeah, there were systems which were using this for consensus and to store the configuration. It is also a key value player, a key. They store key and values associated to that. This is be used in service discovery. This can be used for leader election. This can be used for configuration management. We can use this for distributed locks as well. So we can just simply say a resource and acquire a lock and zookeeper, and that all the nodes will see a lock on that particular system. This can be used for quorum consensus as well. Um, this is Jupyter is highly available and reliable because it's a leader for our architecture. It is if one of the node fails, the other one will become a leader and take place of that. So in that sense, it is again battle tested, something which is already there used by a lot of open source projects like Druid, Flink, Kafka, earlier versions, Cassandra, HBase, Ignite, Pulsar. So all these big databases do use Jupyter itself to create a configuration store. Drawback, uh, it is not what you call horizontally scalable writes. All writes go through the leader, which can become a bottleneck. So that is something which we have to take care of. Then we have ScyllaDB. It's offers similar architecture and format as of Cassandra that we will see next or maybe in upcoming minutes. That so this also has many of the what you call features of a largely scalable, like it's more very fast, and it is very distributed in a sense. It can store very, it can give us high performance and low latency numbers. It is used in for example, the uh, when you look at Geo Hotstar or Disney, uh, not sure of Disney. I think it is in Geo Hotstar, which was earlier Hotstar. So if you have seen continue watching feature, this is that is completely powered by ScyllaDB. So they store the key, which is the content ID and their attribute, and then that is mapped to user ID or session ID, and that's how you see. So whenever you log in from two different devices, if you have watched till let's say a certain timestamp, you instantly see that in the other device as well, that we have already watched till now, and then we can proceed. So it is also, the other thing is this is written in C++, so no JVM overheads, supports DynamoDB compatible API as well. So this is something. And if you see the consistency, the cap theorem, where does ScyllaDB fit? It uses AP, so it is highly available, and partition tolerance it gives, and it is also uh, what you call it is consistency wise, it uses eventual consistency, but again that is not an issue. It generally the writes are reflected very fast. It can be self-tuned. It has server-side scripts using Lua and other stuff. So it is very customizable, and it can be. It has a lot of integrations. It is trusted at large company like Expedia, Discord server, Comcast, Rakuten. So yeah, this is already in production and battle tested as well. Cassandra, although Cassandra is not a pure key value pair, I will say database, but it features in this list because it can be used as a key value store. Generally, it is a hybrid between a column store and a key value store. But again, because of this scale and the way it is geo distributed, we can still use it as a key value pair database to uh, store our configurations. The only thing is Cassandra is write optimized, like it provides very faster writes, but well, like it can give us 1 million writes per second, but it lacks in cases where we have read issues, because this expects the data schema to be designed based on the query pattern. If our query pattern doesn't match, then we will have issues working with Cassandra. But and also, if for the same data set, if we have two different query patterns, we will have to replicate the data twice. So that becomes a challenge. In a sense, it is a drawback of Cassandra when being used as a key value store. We have another key value store, which is Ignite, which is this is an Apache project which is being developed as of now as well. And this provides both in-memory. So generally, for example, Redis is a totally fully in-memory database key value store, but Ignite supports both. Both it has an in-memory cache as well as it stores the data on disk. So the real time means the hot data gets stored in the memory, and the old data gets stored in the disk, and that way it follows an in-memory grid structure, and it is very faster for writes and reads. It can be a very good alternative for Redis if we have certain relaxed latency requirements. It supports ACID transaction, it supports asynchronous automatic synchronization, it has near caching, what we call the data caching. That feature is also there, and it is again based on raft protocol, so raft replica based replication, so it doesn't have the challenges of scale, which comes with generally with Zookeeper based systems. It has we can build a streaming analytics platform using this, often with Spark and Kafka. So this is something which can be used. So Apache Ignite is a project that we should be looking at. From a summary point of view, if you see, there are certain things which each of the database brings and what are their weaknesses. For example, Redis is a single leader. It is eventually consistent. Node discovery is done using Sentinel, and it has hash slots and consistent hashing to do the partitioning. It has a weakness that the data size is limited to the memory that is available in memory data. Cassandra is leaderless. It follows quorum consistency, so it becomes eventually consistent. It does the node discovery using gossip protocol, and the partitioning approach is hash based and requires a lot of expertise to operate. That is the weakness in case of Cassandra. For DynamoDB, we have, again, it is a leaderless system. There is no leader, single leader. It is also eventually consistent. It follows it follows the gossip protocol to share data between our node discovery. It also follows consistent hashing algorithm to decide the partitioning scheme. Now the downside of is that cost is very high and vendor lock-in. XCD is multi-leader, and the leader is elected based on the algorithm. Sorry, consistency is decided based on the raft algorithm, raft consensus algorithm. There is a different service which does the node discovery, which is called discovery service. Again, it uses consistent hashing for partitioning. The challenges with this is defragmentation in large deployments. Zookeeper is a single leader. It follows consistency based on a job protocol, and node discovery happens based on coordinated node that is there. It follows an ensemble partitioning approach, and the configuration is very complex. That's so to maintain or to run a Zookeeper, we require certain special skill sets. ScyllaDB and Apache Ignite we have discussed, so they also have their own pros and cons. Foundation DB is something which is something is being used at many of the places. Now, for example, a new project was there, which is for example, I think Snowflake also uses Foundation DB as their key value pair. For example, if you see Foundation DB is used at Apple, it has being used by Snowflake, Firebolt, Datadog, and Epic Games. So these are very large users of Foundation DB, which again is an open source solution built at, I believe it is was built at Facebook and then later on made open source. This is also is a key value store and a very good place to store configuration. So let's say if you are trying to build something which is in memory, sorry, which requires faster configuration data to be looked up, Foundation DB can be another choice. So this is part one of the series video. We will have part two where we will discuss few other alternatives which are there in terms of key value store and see what options we have in there as an alternative to Redis. So stay tuned for the second part. Thank you.